All right, let's dive into something you might not think about every day: water security in the UK. We're going to get into the hidden crisis that's brewing just beneath the surface of the country's water supply. So when you picture the UK, you're probably thinking of green hills, maybe some drizzle, right? The idea that it could have a serious water problem seems, well, kind of ridiculous. But what if I told you that's exactly what's happening? Yeah, it turns out it's way more complicated than just asking, does it rain a lot? It's all about where that rain falls, when it falls, and honestly, the quality of the water itself. So let's break down that first piece of the puzzle.
Okay, first things first. We've got a fundamental mismatch here. The UK is, believe it or not, a nation literally divided by rain.
And this slide just lays it all out, doesn't it? Over on the left, you've got all this rain hammering down in the west and the north. Think Scotland and Wales. But then look to the right. That's where most of the people actually live, in the much, much drier south and east. So put simply, the water is not where the people are.
So you gotta ask why? Why this huge difference? Well, it all comes down to a process called orographic rainfall. You've got all this moist air rolling in from the Atlantic Ocean. It hits the mountains out west and has nowhere to go but up. As it climbs, it gets colder and bam, it just dumps all that water as heavy rain.
And what happens next is the real kicker. After crossing those mountains, the air is basically wrung out. It's much drier. As it sinks back down on the other side, it warms up, and that creates what scientists call a rain shadow right over the east of the country. And that is the whole reason the east is so much drier.
Okay, so we've got a geography problem. Got it. But there's another major wrinkle here: timing. It's not just about where the rain falls, it's about when we can actually use it.
And to really get this, we need to introduce a key idea: effective rainfall. Now, this isn't just any old rain. This is the good stuff. It's the water that actually manages to get into our rivers and refill our groundwater supplies after you account for all the water that just evaporates right back into the atmosphere.
And this comparison really shows the seasonal split. You know, in the winter, it's cool, so not much water evaporates. That means most of the rain becomes that effective rainfall, which is great for topping up our reserves. But then summer hits. It's hot, tons of water evaporates, and suddenly very little of that rainwater is actually making it into our water system.
And this, folks, is where it gets really tricky. It creates a kind of perfect storm, which you can see right here on this chart. Our demand for water just skyrockets in the summer, right? We're watering our gardens, tourism is at its peak, and this happens at the exact same time our natural water supply from that effective rainfall absolutely tanks. That is the critical summer supply-demand gap.
So, just to recap, we have a problem of space and a problem of time. Now, let's throw a third massive factor into the mix: climate change. It's basically pouring fuel on the fire of these existing issues.
You can just follow the dominoes here. Temperatures go up, that leads to more evaporation and even drier summers, which means, you guessed it, less available water right when demand from farms and homes is at its peak. The end result? Way more water stress, especially in those already dry parts of the south and east.
But hold on, it's not quite as simple as just hotter summers. Climate change is also expected to give us wetter winters. Now you might be thinking, hey, great, more water. But not so fast. When you get these really intense downpours, the water often just runs straight off the hard ground into rivers, which can cause floods instead of soaking in to recharge our groundwater. On top of that, when the rivers are lower in the summer, any pollution that gets in becomes way more concentrated and a lot more dangerous.
And that brings us to our last and honestly one of the most critical points. This isn't just about how much water we have, it's also a crisis of quality. The water we do have is under a serious and growing threat from pollution.
So where's all this gunk coming from? If you look at the chart, you can see the main culprits. A huge chunk is agricultural runoff. We're talking fertilizers and animal waste getting washed into our rivers. Then you've got the sewage system, which is a big one, from both treated wastewater and, you've probably heard about this, those controversial storm overflows that release raw sewage. And of course, there's also illegal dumping from industry. So what does all that pollution actually do? Well, one of the worst consequences is something called eutrophication. All those extra nutrients from farms and sewage are like rocket fuel for algae. You get these massive, thick algal blooms that cover the water. They block out the sunlight, and then when they die and rot, they suck all the oxygen out of the water. This creates these underwater dead zones where fish and other wildlife just can't breathe.
And the cost of this pollution is just staggering. It's not just about the dead fish. It creates real health risks for us. It means water becomes more expensive for everyone because it costs more to treat. It hurts industries like tourism and fishing. And the bottom line is, it shrinks the very amount of usable freshwater we have to rely on, making our scarcity problem even worse.
Okay, so let's just pull this all together for a second. The UK's water crisis really boils down to 4 big problems crashing into each other. You've got the geographic mismatch, water's in the wrong place; the seasonal gap, demand is highest when supply is lowest; climate change, which is making everything worse; and finally, the quality crisis. The water we do have is getting polluted. Each one is a huge challenge, but together, they are a serious threat.
And this is where we're left. The pressures are all building. More people, a changing climate, ongoing pollution. With a shrinking supply of clean, usable water, the challenge is massive. So the final question really is, how is a famously rainy island going to secure its water for the future?